we are covering calculus, and we are going to handle questions involving calculus that we are done in KCSE year 2017, 2018. You can also have 2018, 2019, and another 2019. We can begin with this question where we've been told that the distance covered by a moving particle through point O is given by the equation S is equals to t cubed minus 15 t squared plus 63 t minus 10. Then you'll be told to find A, distance covered when t is equals to 2. Here we have 2 marks. And in this, what you're supposed to do in this, you just substitute. This is the equation for the distance. S is equals to 2t cubed minus 15t squared plus 63t minus 10. So we are going to substitute. Where we have t, we replace with 2. To have S is equals to t is 2 cubed minus 15 times 2 squared plus 63 times t, but t is 2 minus 10. To have t cubed is 8 minus 2 squared is 4. 15 times 4 is 60 plus 63 times 2, 126 minus 10. To have 8 minus 60 plus 126 minus 10, supposed to be 64 meters. That is the distance. Next we've been told to calculate the distance covered during the third second. The distance covered during the third second. This third second is supposed to be the difference between the third and the second. Difference between the B, distance covered during third second. 3 marks. 3 marks. And here I'm saying that you are supposed to get the distance covered during the third second. You subtract the distance covered during the second distance. And now that we have calculated the distance covered during the second distance, we are going to, second, we are going to subtract. You take the same equation S is equals to, or you have t, we are going to replace with 3. 3 cubed minus 15 times 3 squared plus 63 times 3 minus 10. You can just use the calculator directly. 3 cubed is 27. Then minus 15 times 9 plus 63 times 3 minus 10 to get 71 meters. So this is the distance covered during the third second. This distance covered during the second is 64. So the correct answer will be, you take 71 minus 64. To get 71 minus 64, you get 7 meters. Your 3 marks are there. Next, the time when the particle is momentarily at rest. Time when the particle is momentarily at rest. 3 marks. And here you are going to say that we know that the particle is momentarily at rest when v is equals to 0. That is, the speed is 0. This is how we go about it. S v a, where this is a distance, we have speed, acceleration. From S to A downward, we do differentiate. From acceleration to upward, we integrate. Now we are coming from distance to v, velocity, and the particle is momentarily at rest when v is 0. What we are going to do, we differentiate this equation with respect to t. Differentiate this equation with respect to c and say ds over dt is equals to 3t, then 3 minus 1 is 2, it will be 3t squared, then 15 times 2 is 30, t, 2 minus 1 is 1, plus 6, here we have 1 times 63, it's 63. 1 minus 1 will be 0. This is the equation for v. And this is the equation we are going to equate with 0, because the particle is momentarily at rest when v is 0. V is equals to 3t squared minus 30t plus 63 is equals to 0. V is 0. 3t squared minus 30t plus 63 is equals to 0. 3, 30 and 63 are divisible by 3. You can first of all divide by 3, by 3, by 3 to have t squared minus 30 divided by 3 is 10. 10t plus 63 divided by 3 will be 20. 21 is equals to 0. Now this is a quadratic equation. You take the first, we have 1 times 21 is 21. Then from the factors of 21, we want, when we subtract the larger number, the smaller number, we subtract the larger number, we get negative 10. Factors of 21, using the three-factor method, we have 3 and 7. 3 times 7 is equals to 21, but negative 3, negative 7 is equals to negative 21. It's negative 10. When we have negative 10, we can replace with negative 3t, negative 7t, to have t squared minus 3t minus 7t plus 21 is 0. Common, I can see GCD t minus 3 minus 7, t minus 3 is equals to 0. T minus 7, t minus 3 is equals to 0. Each bracket we equate with 0, and t will be 7 or 3. Yeah, so this is the time. This will be the time when the particle is momentarily at rest. T is equals to 7 or 3 seconds. Yeah, so this is the time when the particle will be at rest. And the particle will be at rest. Next, the acceleration when t is equals to 5. The acceleration. Now, we are going to differentiate the equation of velocity to reach at acceleration. This is the equation of the velocity, it's here. You differentiate it again to get the equation of acceleration. Acceleration, yeah, this equation we are going to differentiate with respect to t and say that a is equals to dv over dt, which is equals to 3 times 2 is 6, t minus 30, like that. This is the equation for accelerations. A is equals to 6t minus 30, and A will be, and you've been told that the acceleration when t is equals to 5 time 6 times 5 is equals to, 6 times 5 minus 30. Acceleration will be 30 minus 30 is equals to 0 meters per second squared. 10 marks. That's how you're supposed to handle that question. Next, you'll be given the equation of a curve is, this is the equation of the curve, y is equals to a third x cubed minus 4x plus 5. Determine the value of y when this a value of y when x is equals to 3. Value of y when x, just substitute and say y is equals to 1 over 3 times 3 cubed minus 4 times 3 plus 5. That way, y is equals to a third times 3 cubed, it's 27, 4 times 3 it's 12 plus 5. By 3 1 by 3 9, y is equals to 9 minus 12 plus 5. 9 plus 4 it's 14. 9 plus 5 it's 14. 14 minus 12 it's 2. In terms of coordinates, we are going to have x it's 3, y it's 2. B, the gradient of the curve at x. The gradient of the curve at x. B, gradient of the curve at x is equals to 3. X is equals to 3. To get the gradient, you have to differentiate this equation this way and say that dy over dx, changing y over changing x. Changing y over changing x means gradient is equals to, come here, 3 times a third, then x squared minus 4. Good here. So that is the way, by 3, 1 by 3, 1. Dy over dx will be x squared minus 4, which is equals to, x is equals to 3. 3 squared minus 4 is equals to 3 squared, it's 9 minus 4, 5. And gradient, changing y over changing x, will be 5. Next, the turning points of the curve and their measure. The turning points of the curve and their measure. I can rub this part. Don't rub. Turning points. To get the turning points of a curve, first of all, the gradient equation, you equate the gradient with the 0 to get the value of y. This equation here, dy over dx is equals to x squared minus 4. This equation you are going to equate the gradient function, you equate with the 0 to get two values of x. This way is equals to 0. X squared minus 4 is equals to 0. X squared minus 4 is the same as x minus 2. X plus 2 is equals to 0. Each bracket you equate with 0 to have x minus 2 is 0 and x is 2, or x plus 2 is 0, x is equals to negative 2. Then that being the case, we have two x's, one of them is 2. Then we are going to get the value of y. We have the other one, it's x is negative 2, comma. You come to the initial equation of y, you substitute y is equals to a third times 2 cubed. 2 cubed minus 4 times 2 plus 5. To have 2 cubed is 8 over 3 minus 8 plus 5. To get what? You can use a calculator to avoid wastage of time. 8 over 3 minus 8 plus 5 to get negative a third. Next, we are going to have, you replace -2, the same equation, the same y function, y, where we have x, now you substitute with -2, and then times -2 cubed minus 4 times -2 plus 5 to have -8/3 plus 8 plus 5 to have what? -8/3 plus 8 plus 5 to have 10/1/3. 10/1/3. Then we proceed. That's how you're supposed to do that. You've been told the turning point of the curve and their nature. So under this nature, you are supposed to say whether it's maxima or minima. To help you know whether it's supposed to be maxima or minima, you move to y coordinate. Y coordinate, the larger number is supposed to be maxima. Here we have 10/1/3 and we have -1/3. Between -1/3 and 10/1/3, which one is larger? It's 10/1/3. And we are going to come very comfortably say that this is maxima. Then we have -1/3. This will be minima. To know minima or maxima, check on the y coordinate, not x, y coordinate. This is 10/1/3 is greater than -1/3. And that's how you are supposed to handle that question, which was done in 2018. Again, 10 marks. You can also have another question on the same, similar to that. Calculus. You've been told that the equation of a curve is y is equals to x cubed plus x squared minus x minus 1. Determine the stationary points of the curve. The stationary points of the curve, this is A. Determine the stationary points, the stationary points of the curve. To get the stationary points of the curve, you are going to get this equation. You differentiate dy with respect to x. You are going to get the gradient function. That gradient function we are supposed to equate it with 0. You are supposed to get the two values of x's like this, that dy over dx is equals to 3x, then 3 minus 1 is 2, plus 2, then x, 2 minus 1 is 1, like that, minus 1. This equation you are going to equate it with 0 to have 3x squared plus 2x minus 1 is 0. 3 times 1 is 3. Factors of 3, where the larger one you subtract the smaller one, you are going to get positive 2. 3 times 1 is 3. Then 3 minus 1 is 2, positive 2. So we are going to have 3x squared plus 3x minus x minus 1 is 0. So that 3x minus x will be 2x. It will turn the way it was. GCD of 3x squared and 3x is 3x. Then 3x squared divided by 3x is x, plus 3x divided by 3x is 1. Negative 1x. Negative divided by negative is positive 1 is equals to 0. 3x minus 1 x plus 1 is 0. You equate each bracket with 0. 3x is equals to 1 divided by 3 by 3. And x is equals to a third. X plus 1 is 0. X is equals to negative 1. Now, you are going to pick these two coordinates for x's, they will help you to know whether the stationary points will be maxima or the nature of the curve. The nature of the stationary points. The nature of the stationary points of the curve. Then come here. One of the x's is a third, comma, the other one is a -1. Pick this a third, you substitute where we have x, like this. Y is equals to 1/3 cubed plus 1/3 squared minus 1/3 minus 1 to get 1/3 cubed is 27 plus 1/9 because 3 squared is 9 minus 1/3 minus 1/3 minus 1 to get negative 1/5/27. Negative 1/5/27. Is it? You can confirm 1/27 plus 1/9 minus 1/3 minus 1. Yeah, it's okay. Then for the second one, y is equals to -1 cubed plus -1 squared minus -1 and you are going to have -1 plus 1 plus 1 minus 1, it's 0. Yeah, it's supposed to be, let me see, yeah, it's supposed to be 0. Then you'll be told the nature of the stationary points in A above. Yeah, so come here. I've told you that if you want to know whether the point is maxima or minima, check on the y coordinate. We have negative and we have 0. Between negative and 0, which one is larger? It's 0. So this coordinate will be maxima and this one will be minima. Yeah, and you are going to score your 10 marks. No, but yeah, so this was part A, carrying 5 marks. We proceed to part B. Determine the equation of the tangent to the curve. Equation of the tangent to the curve. Equation of the tangent to the curve. Equation at B Roman 1. Equation of the tangent to the curve at x is equals to 1. First of all, we can get the other coordinate. We know that x is 1. What of y? To get y, get this equation and substitute where we have x with 1. Y is equals to 1 cubed plus 1 squared minus 1 minus 1. To have 1 plus 1 minus 1 minus 1, it's 0. Yeah, that is the coordinate. Then next you get the gradient of this curve. The gradient of this curve is supposed to be equal to the equation of the tangent to the curve at x is equals to 1. It's like m1 will be equal to m2, or the gradient of equation 1 will be equal to gradient of equation gradient of equation 1 will be equal to the gradient of equation 2. Why is that equation? The gradient, it's here. Determine the stationary point. Yeah, we have differentiated. Yeah, so this is a gradient function. dy over dx is equals to 3x squared plus 2x minus 1. And you can say gradient 1 is equals to 3 times x is 1. X is 1, you substitute 1 squared plus 2 times 1 minus 1. This will be 3 plus 2 minus 1, and it's 4. G1, gradient 1 is equals to gradient 2, which is 2 there. Now the examiner wanted us to get the equation in the form of the equation of a straight line. And how do we get the equation of how do we get the equation of a straight line? Equation of a straight line is in this way, or in this format: y is equals to mx plus c. We have the coordinate 1, 0, x, y, but gradient is equals to change in y over change in x. Gradient is what? Gradient is 4 here. Y, change in y, y minus 0, or of a change in x, x minus 1. To have y minus 0 is equals to 4, x minus 1. Open the bracket, y will be 4x minus 4. And this is the equation that we are supposed to compute there. We move to Roman 2 of the same. Roman 2. Roman 2. Roman 2 being told the equation of the normal. The equation of the normal to the curve at x is equals to 1. What this means, the word normal means that the two equations, they will meet at perpendicular. They will meet at an angle of 90 degrees. And this way we are going to apply the formula m1 times m2 is equals to negative 1. The gradient of m1 is where? It's here 4. You say 4 times m2 is equals to negative 1. Divide by 4 by 4. And m2 negative 1 negative 1 over 4. This is the gradient of a point part seen at this coordinate 1, 0. We now want to get the equation of that perpendicular normal curve. Normal line or gradient. So 1, 0, x, y minus 0. Gradient is equals to change in y over change in x is equals to gradient, which is negative 1 over 4. You cross multiply to have 4 y minus 0 is equals to negative 1 x minus 1. 4y minus 0 is equals to negative x, negative and negative, positive 1. 4y is equals to negative x plus 1. Divide by 4, can divide by 4 by 4 to get y is equals to negative 1 over 4x plus 1 over 4. Yeah, that's how we're supposed to handle that question. And finally we can also have this. Today we are covering calculus. Calculus topic in Form 4. Yeah, you've been told that this was done again in 2019. Find the coordinate of the turning point of the curve. Y is equals to x squared minus 14x plus 10. You get the coordinates of the turning point. Coordinates of the turning point. You are going to differentiate this equation to get the gradient function. That gradient function you are equated with 0. dy over dx is equals to 2x, 2 minus 1x, 1. So we are going to have 2x minus 14. This is the gradient function. Now equated with 0 is equals to 0. To have 2x minus 14 is equals to 0. 2x is equals to 14. Divide by 2 by 2. And x is equals to 14 divided by 14 divided by 2, it's 7. One of the coordinates we have 7. The coordinates of the turning point of the curve 7. 7. Then you get y. You substitute y is equals to 7 squared minus 14 times 7 plus 10. y is equals to 49 minus 14 times 7, 98, plus 10, to have 49 minus 98 plus 10 is equals to negative what? Negative 39. Negative 39. And the coordinates of the turning point of this curve is supposed to be 7, negative 39. Negative 39. Finally, you've been given that the displacement s meters of a moving particle after t seconds is given by s is equals to 2 over 3 t cubed minus 7 over 2 t squared minus 6t plus 8. Yeah, this is a displacement. And remember we said that SVA, displacement in meters, speed, velocity, acceleration, meters per second squared. Downwards it's a differentiation, upwards it's integration. Now we've been told it's a question that was done in 2020. Determine the A, velocity of the particle when t, A, velocity of the particle when t is equals to 5. 3 marks. This is S, displacement. You want to move from S to V. Downwards is differentiation. We are going to differentiate this equation S with respect to t. V is equals to ds over dt, which is equals to 3 times 2 over 3t squared minus 2 times 7 over 2t, but 2 minus 1 is 1, minus 6 by 3, 1 by 3, 1 by 2, 1 by 2, 1, and v is equals to 2t squared minus 7t minus 6. V is equals to what? 2 times t is what? 5. 5 squared minus 7 times 5 minus 6. 5 squared is 25. 2 times 25 minus 35 minus 6. 2 times 25 is 50 minus 35 minus 6. To get 50 minus 35, this 50 minus 6, you get 9 meters per second. That is the velocity. Those are 3 marks. Next, determine time t seconds when the particle is momentarily at rest. The particle is momentarily at rest when equation of the speed is 0. When v is equals to 0, the particle is momentarily at rest. So we are going to equate this equation with 0 to get time. V is equals to 0. V will be 0 when the particle is momentarily at rest. Equate this equation with 0 to have 2t squared minus 7t minus 6 is equals to 0. 2 times 6 is 12. Factors of 12 that will give us negative 7. We can have, this is 2t squared. We can have 4 times 3. 4 times 3 it's 12. And again, negative 3, negative 4, it's negative 7. When we have negative 7t, we can replace with negative 3t, negative 4t, negative 6, it's 0. Like that. Then after that, 6 times 2, 3, negative 4, so as to have, or you've been told to, the time t when the particle is momentarily at rest. The time t seconds when the particle is momentarily at rest. After differentiating, we got 2t squared minus 7t minus 6. Factors of 12. 12 3 times 4. We have 6 times 2. We also have 12 times 1. What else? Those are the factors. The one that was supposed to give us the correct answer was 3 times 4. 2 times 6, it's 12. Then negative 4 plus 7, it's 7. Okay, we can as well use this equation. T is equals to negative b plus or minus b squared minus 4ac all over 2a. So that we can have negative b. Negative b will be, this will be ax squared plus bx plus c is equals to 0. B will be negative 7 plus or minus b squared. B squared it's here. We pick negative 7 squared minus 4 times a, it's 2, times c, negative 6, all over 2 times a. 2 times a, it's 2. So that you can have negative 7 plus or minus root 49 plus 8 times 6, 97 all over 4 to get root 97 to have 7 plus or minus 9.84 all over 4. One of the values of t, one of the values will be 7 plus 9, plus 7 plus 9.8, you divide by 4, there will be 4.21 seconds. The other one will be 7 minus 9.84, you divide by 4 to get negative 0.71 seconds. That's how you are supposed to handle it. Then next, displacement is when the particle is momentarily at rest. Displacement is when the particle is momentarily at rest. You are going to take these t's, you substitute in this equation to have where is my duster? My duster. Kanab. And say that S is equals to 2 over 3 t cubed minus 7 over 2 t squared minus 6t plus 8. S will be, we can take the positive one, 2 over 3 times 4.21 cubed minus 7 over 2 times 4.21 squared minus 6 times 4.21 plus 8. S will be, can use a calculator, 2 over 3 times 4.21 cubed minus 7 over 2 times 4.21 squared minus 6 times 4.21 minus 8 to get negative 45.58. Then for the other one we can have s is equals to 2 over 3 times negative 0.71 cubed minus 7 over 2 times negative 0.71 squared minus 6 times negative 0.71 plus 8 to have negative 2 over 3 times 0.71 cubed plus 7 over 2 times 0.71 squared plus 6 times 0.71 plus 8 to get 13.785. And since a distance cannot be negative, you can drop this negative and pick the positive one. You pick the positive one. And finally, acceleration of the particle when t is 4. Acceleration of the particle when t is equals to 4. Acceleration, we are going to differentiate our v equation, but we have deleted it by mistake. We can differentiate. We can say that v is equals to ds over dt to get 3 times 2 over 3 t cubed minus 2 times 7 over 2 t minus 6. V is equals to, velocity will be 2t cubed minus 7t minus 6. Then, but you want acceleration. You differentiate again. You proceed and say that acceleration is equals to dv over dt, which is equals to 6t squared minus 7. Acceleration when t is equals to 4. You just substitute 6 times 4 squared minus 7, and this will be 6 times 16 minus 7. 6 times 16 minus 7 is equals to 89 meters per second squared. And that's how you're supposed to handle calculus. That's how the calculus is done. It's a simple topic. And bye for today.